Unfortunately, we have to leave our CBA alone for now. We can work on it when we get back to school. The next thing we're going to look at is sets and probability. When I have this video recorded, it'll be attached on this page, and you'll watch the video, pause the video when you're prompted to, and complete the questions as you're asked. And I want you to upload photos of your work into your private section on this OneNote under your own name. Title the page with today's date, which will be the 19th of the 3rd, 2020. The work that you need to complete is on page 238 to 241 of your book, and our learning intentions for today include reviewing sets, everything we learned in first year. Then we have two new things for us today, which are set difference and the complement of a set. So where you can find the content for this, so within our second year's class, we have our school closure there, and then once we go down to the content library, once we click into sets, this is where everything will be. So we have our review here first of all, and then we have the set difference and complement bit there. What I would like you to do is to quickly pause the video and try to write down as many things about sets that you can remember from last year on a piece of paper. So it could be simple things like definitions or a diagram or anything along those lines, anything you can remember from sets fresh from your head. See how much you can remember before we get stuck into it. So once we actually get to look into these things now, so these notes again are just taken from your book, okay? So first off, when we talk about a set, we remember what a set is. So a set is a collection of things, objects, or symbols that are well defined. So the well-defined bit is really important there. So I know it's already in bold, but it's well highlighted as well. Anytime you look for a definition in an exam, you always want to make sure you have well-defined included in the definition. The objects that make up a set are called its elements or members of the set. It gives an example here. So it says we have a set A and its elements are 1, 3, 5, 7 and 9. So we can see again that when we're listing out the elements of that set, we have to use curly brackets and then we have to use commas in between them. So again, if we want to draw our curly brackets, they want to look something like that or something along that. Okay, it doesn't really matter too much, but once your curly brackets look something like that, then you're okay. So we have two other symbols here we have to look at. So first off, we have this one here. So it's like 5 with the E, A. So we want to say if 5 is an element of the set A, we write 5 and then that little symbol which is like an E to A. And if we want to say that something is not an element of the set, so we take the example of the number 6 was not included in the original set. If we want to say 6 is not an element of the set, we write down 6 is not an element of A. And how we do that is by in between the 6 and the A, we write the E again, but with a slash across it. The cardinal number of a set, so we see the hashtag symbol there, that means cardinal number in sets. So the cardinal number of a set is the number of elements or members in the given set. So for example, the cardinal number of the set A that was given to us had a cardinal number of 5 because there was 1, 3, 5, 7 and 9. So that's a total of 5 different elements in the set. A set is a null set if it contains no elements or members. So symbols for the null set are the empty curly brackets or a 0 with a line straight across it like that. So example of an empty set we could think of very quickly would be Liverpool players who've won the Premier League or anything along those lines. So something that there's no members of the set. Then we have equal sets. So two sets are equal if they have the same elements. For example, the set A is 2, 4, 6 and 8 and the set B is the set of even natural numbers less than 10. So even natural numbers less than 10 would be 2, 4, 6 and 8. So that means these two sets are equal. We can write down A is equal to B, and if A and B are not equal to each other, we would write A is not equal to B. So that's the equal symbol with a slash across it. Then we can move on to subsets. So B is a subset of A if every element of B is also in set A. So for this particular example, for some reason, they've done different types of screwdrivers. So we can see in the set A, there's 5 different types of screwdrivers there. And in the set B, there's 2 different types. And we can see that this yellow one here is also in this one. And this shorter red-handled one is the same as this short red-handled one here. So these two elements are both in the set A as well. So then we can write B is a subset of A. Then we remember we moved on to Venn diagrams. So we often use Venn diagrams to represent sets. So the Venn diagrams are two overlapping circles, and we have to be able to talk about how they relate to one another. So this intersection of A and B is written down as A intersection B, and that's just written here in the middle. So that's A intersection B. It's the set of all common elements that are in set A and in set B. So if something is in the set A and it's in the set B, it goes in the middle, which is highlighted here. That's the intersection of A and B. So the intersection of A and B, so we see here we have A intersection B is the same thing as B intersection A for all sets A and B. Then we can say that the intersection of the two sets is commutative, because it doesn't matter which way you say it. It's the same as me saying my name is Connell or Connell is my name. The order doesn't matter. Then we have the union of two sets. A union B is the set of elements which are in A or in B or in both of them. So that includes the middle, like the intersection, but then it also includes the rest of A and the rest of B as well. So every single bit of A and B is included in A union B. And again, it has the commutative property. So A union B is the same thing as B union A, as written there. The universal set is the set that contains all the elements in the given question or problem. The symbol U is used for the universal set. So whenever we want to talk about the universal set, that's when we have to do this box around the Venn diagram. So that includes it out. Now, if we want to describe a set, we have two ways of describing a set. One is the written method. So, for example, C is the set of odd numbers greater than 5 but less than 20. And the listing method is where you take the same set but you list out all of its elements rather than writing out the rule for it. We also have another way to describe sets using symbols. So this is called the rule method, also known as set builder notation. This will be a bit new to us this year. So for example, the set C is equal to X such that X is the set of odd numbers greater than 5 and less than 20. So we can actually see it written down here in the very bottom is where it's explained out to us. So C is the set of all X such that X is an odd number greater than 5 and less than 20. And the question, just the way it's set up is it uses X as an example to mean it could be any element. So any element of this set is an odd number greater than 5 but less than 20. So we have an example done out here where describe each of the following sets in two different ways. A is the set of vowels in the English alphabet, and it gives two ways to list them out. So first off, we have the list method where we just go A, E, I, O, U, separate them with commas and put curly brackets around them. That's nice and handy. And then it has the rule method. So the rule method says X, all of X, such that it is a vowel in the English alphabet. Then the next question says B is the set of the odd numbers between 10 and 20. First method lists them all, so it goes 11, 13, 15, 17, 19, no problem there. Then the second method uses the rule method. So B is the set of all X such that X is an odd number between 10 and 20. Now, what I've listed down here for us is an example of all the different types of notation we've met before. So we will have seen that before last year, curly brackets. We've seen A union B, we've seen A intersection B, we've seen a subset, we've seen not a subset. This one we're going to learn about today, that's complement. And this one we're going to learn about today, that's A less B, A without B. Then we have A is an element of A, we have that, B is not an element of A, null set, and empty set, and universal. So those two are the two new ones we're going to learn about today. Now, task for you guys is to pause the video right now, look at these questions which are on page 338. So I have question 1 through to 9, and give yourselves 20 minutes, set the timer on the clock, give yourselves 20 minutes and see how many of these questions can you get done within 20 minutes. And now we can look at set difference and complement. So first off, I have a Venn diagram drawn out here. So we've said that we have the set of all X such that X is an even number less than 10. So if I want to list out the elements of A now, well, A will be equal to even numbers less than 10. So even numbers less than 10 will have 2, we'll have 4, we'll have 6, we'll have 8, and we won't have 10 because the question very specifically said less than 10, not less than or equal to. And then we have x such that x is a factor of 6. So factors of 6 are numbers that we multiply by each other to get 6. So if I multiply 1 by 6, then I'll get 6. And if I multiply 2 by 3, then I'll get 6. The factors of 6 are 1 by 6, 2 by 3, 3 by 2, and 6 by 1. But I obviously don't want to list any element out more than once. So now when I look into filling out my set, first off I have to think, okay, is there any element that's in A and is in B? So I'll have a look here. Well, I have 2 is in both of them, and I have 6 is in both of them. So 2 will have to go in the middle here, and 6 will have to go in the middle here. Then I can look at filling out the rest of A. So A also has a 4 and an 8. So 4 can go in here, and 8 can go in here. B also has a 1 and a 3. So 1 can go in here, and 3 can go in here. And I've set the condition on the bottom here that U is the first 10 natural numbers. We can see that here, okay? So I have 1, 2, 3, 4. I don't have 5 included, so 5 will have to go outside the two sets. I have 6, I don't have 7, so 7 can go outside. I have 8, I don't have 9. And let me think, the first 10, so I'll count through 1, 2, 3, 4, 5, 6, 7, 8, 9. For the first 10 natural numbers, 10 will be on the outside as well. So that's my review on how to fill out a Venn diagram. Now, first off, we have set difference. So we can see here we have A slash B. So A slash B, called A less B, is the set of elements that are in A but not in B. So if we look at the Venn diagram here, the first one, we can see the shaded region there is the parts of A that are not also in B. So if I want to list the elements that are in A less B, or A without B, I'll look up here. So what parts of A are not in B? Well, 2 and 6 are in B as well, and 4 and 8 are not. So what will go in here will be 4, 8, and I'll close off my bracket. Then I look at B less A, and B less A is the parts of B that are not also in A. So I have 1 and 3 are both in that middle part of B, but not in A. So 1 and 3 will go in there. So again, A slash B is this highlighted bit here, as best as my colouring and abilities will allow, and B less A is this part of B that is not in A. Now, when I go down to the complement of a set, so it gives the example here. B complement, or B dash, is the set of all elements in the universal set that are not in B. So this is given the example here of the first one, which is B complement. So the only thing that isn't highlighted is the circle B. So everything that's not inside the circle B is B complement. So we exclude B if we use B complement. So we're going to exclude 1, 2, 3, and 6. So on our set, we're going to have 5, 7, 9, 10, or even, sorry, we have 4 as well. So we have 4, 5, 7, 8, 9, 10. So we have 4, 5, 7, 8, 9, and 10. And I just want to double check that. So we have 4, 5, 7, 8, 9, and 10. So 1, 2, 3, and 6 are all in B. So we have to exclude those 4. Then when we look at B complement, the complement of a set. So B complement, otherwise known as B dash, is the set of all elements in the universal set that are not in B. So that means B complement is the universe without B in it. So if we look at this first example here, it's of B complement, and the second one is of A complement. So after seeing that now, I'm just going to swap around two of these. So the first diagram is for B complement, and the second diagram is for A complement. So we'll keep it a little bit simpler if we have B complement and then A complement after it. So if we go up to our example, B complement will be every single element that is not in B. So first off, we need to think what is in B. So 1, 2, 3, and 6 are all in B. So we need to include every other element that is not in B. So let's see, which is not in B? Well, we have 4, 5, 7, 8, 9, and 10. So that's 4, 5, 7, 8, 9, and 10. Now, it doesn't matter too much if you don't write them in the correct order. You could have said, well, 4 and 8 are an A, and then 7 and 9, 5 and 10, but I just did them in order. It was a little bit easier for me. Then if we look at A complement, we look at the diagram. So A is not highlighted, so it means everything except A. So if we look at our example now, A has 2, 4, 6, and 8 in it. So everything except 2, 4, 6, and 8, well, A was the even numbers, so that means everything that's not an A will be our odd numbers. So we have 1, 3, 5, 7, 9, but then we have 10 as well, because the A was even numbers less than 10. So for the complement of A, we'll have 1, 3, 5, 7, 9, and 10. So they're all the elements that are not in A. So that's A complement and B complement. Now things can get a little bit more complicated, and we could have something like A union B complement. So that'll mean everything that's not in A and not in B. So A union B will be 4, 8, 2, 6, 1, and 3. So everything outside the two circles is 5, 7, 9, and 10. So we just need to include 5, 7, 9, and 10. So that's 5, 7, 9, and 10. And close off our curly bracket. We could also look at an example which might be A intersection B complement. So that'll mean everything that's not in the intersection. So if we look at what the intersection was, well, the intersection was 2 and 6. So everything except 2 and 6 will be 1, 3, 4, 5. I need to skip 6, 7, 8, 9, and 10. So that's everything that wasn't in A intersection B. So set difference to review. A slash B means A less B. That means everything that's in A that is not in B. Then if I have B complement, it means everything that is not in B. If I have A union B complement, that means I have everything that's not in the union of A and B. Now again, the questions I want you guys to have a go at are on page 340 of your book, and you have questions 1 through to 8 there. And what I want you to do is I want you to do as many of those questions as you can get done in 25 minutes. So again, when you're doing these questions, go into your own personal private tab, set a tab up underneath today's date, title it today's date, and then submit the work for me to correct. And then hopefully at the end of today, you'll have been able to review everything we did in first year in sets, and you'll know the difference between set difference and the complement of a set. And all in for today's lesson and what will be homework over the weekend, you shouldn't be looking at more than an hour and a half, absolute maximum to get everything done.